there, I'm Ash and I'm from ScienceWorks, and we're gonna learn a little bit about secret messages in coding today. And I have a secret message right here. These candy hearts are spelling out a secret message. So let's look and see if we can figure out what it says. So I'm noticing there's a pattern to these candy hearts. I'm noticing each row has some yellow and green hearts, and they're not all in the same pattern from one row to the next. And I also have a binary code chart here. We're going to talk more about binary in a minute. We're going to see if we can decode this message. So code is any kind of arrangement of symbols that represent letters or numbers. And so we could make a code with a lot of different things. And binary refers to when there's two options. So if you think of a light switch is an example of binary, because if we flip the switch up, the light is on. If we flip the switch down, the light is off. So when we're talking about binary code for computing, we're talking about the number 1 and the number 0. So I'm predicting that one of these candy heart colors is representing a 1 and one is representing a 0. And I think we can look on our binary code chart and we can see what those letters are represented in the 1s and 0s of binary. So I'm looking at my chart and I'm noticing that every letter in binary starts with a 0. So I think that the yellow hearts represent 0s. And that means the green hearts must represent 1s. So I'm going to look here, and our second number in our binary code for every letter is a 1. We've got a 0, we've got a 1. So now I'm looking for something with just 2 zeros after it. There's quite a few numbers that could just have 2 zeros. And then a 1. So I'm looking for a number that's 0, 1, 0, 0, 1, 0, 0, 0. There's only one letter that has that, and that's an H. So this first letter is H. We can go through and we can decode every single line of this binary chart using this method. So I'm looking for a 0, 1, 0, 0, 0, 1, 0, 1. So I'm going to look at my chart. I found it, and it's an E. So our message so far, it says H-E. Now I'm looking for 0, 1, 0, 0, 1, 1, 0, 0. It's L. And now I'm looking for 0, 1, 0, 1, 0, 0, 0, 0. And that's P. So someone has left me a secret message in binary that spells help. So I want to find out who needs help. But they probably don't need help in a big emergency because they took the time to write me a binary message. So I'll find out who my friend at work is who wants to send me a secret message. So as we were talking about binary numbers and coding, we're also going to talk about how weaving relates to coding. And weaving is when you take threads and you weave them over and under other threads in a loom, and you can create a pattern like this. So weaving is a really, really ancient textile art. It goes back to the Stone Age, and people have used it to create cloth. Maybe if you ever look really, really closely at your shirt or at a carpet, you might be able to see that there are threads going over and under, and they can make patterns. So just like we were talking about how anything with those two states a binary is represented by two states. When weaving, that over and under represents binary 2. And so around the 19th century, there was a lady called Ada Lovelace, and during the Industrial Revolution, there was a lot of improvements in weaving machines. So people could make these woven patterns a lot quicker because they were actually programmed. The machines were programmed to do that. So Ada Lovelace saw one of these automated looms, and she imagined that maybe someday there could be a machine that could be programmed with punched cards of paper in binary to make patterns or music or write letters or even make art. So she was kind of imagining that someday we could code a computer type machine with binary code and do all the things that our computers can do. And she wrote a program for this machine. She's called the grandmother of computer programming. So I want to show you guys how we can make a pattern using binary, and we can use that to make a woven project with paper. So now we're going to look at how we can write a secret message with binary. And so for my secret message, I want to write my name. And I want to have my name in binary. So first thing I'm going to do is I'm going to look up how to make an A in binary. So what we'll do is I'm going to write out the letter code for a binary A, which is 01000001. And now I'm going to plot it on my grid. I'm going to leave my blank squares representing 0, and I will color in the squares I want to represent 1s. So in A, we just have 2 squares representing 1s. So for row 2, I'm going to find the S on my code. And let's say I want to use a small s. I'm going to go to the code chart that has the small letters. And a small s code is 0111 0011. So then I'm going to plot that on my code chart. So I'm going to just fill in the squares that are 1s. And I know there's 2 1s on the end. And we'll have a small h. So that's a 0, 1 1 0 1 0 0 0. And you don't have to fill in your squares perfectly because this is just kind of a little template for you to refer to as you make your code. We're going to have, I'm going to be fun and I'm going to put an exclamation mark after my name. So I'm going to go to this page where we've got the binary code for symbols. And so I'm going to find the exclamation mark, and that is 001 00001. And then we'll just plot that onto our chart. And let's say I had wanted to use, maybe I want to write a word that has an accented letter you can find those accented letters on this page too. So if you have any letters in your name that have any kind of accented characters, you'll look on this page. So the next thing we're going to do is we're going to make a little paper loom for us to weave out our design. So what I'm going to do is I'm going to take a piece of paper, I'm going to fold it over once, I'm going to fold it over again, and one last time. And this is going to be like the warp strings or the up and down strings on a loom when we cut our paper. As you can see, we've got our folds, and then I'm going to fold it over. And this middle fold is going to be my guideline for when I cut my slits into my paper. So just go like this. And I'm just going to cut my slits in the paper following along the folds I made. I also cut out some thin strips of colored paper, and that's what I'm going to use to weave my design. So when you finish, your little paper loom is going to look like this. All right, so now we're going to weave in our code. So I'm going to look at my sheet where I plotted everything out, and I see I go 0, 1, 0, 0, 0, 0, 0, 1, and that's going to translate to under 1, over 1, under 5, and then over 1. And so when we get our coded messages finished, we can do some really fun stuff with this. You could make some placemats. So you could make a coded name message for everyone in your house, and then you could maybe just laminate over it, and everybody could have their secret message placemat. Or you could give it to a friend, and it could be like a password that you guys could use with each other. Or you could trade secret messages back and forth. So we're going to go for row 2. We're doing that lowercase s, under 1, over 3, under 2, over 2. And if you have a really long name, you know, you might make your strips thinner than this, but I have a nice short 3-letter name, so I can use big, thick strips. And for our third row, we're going to go over or under 1, over 2, under, over, and then under 2 and over 1. And when I finish this, I'm going to tape my strips on the back so that they stay where I want them to be, because you can see they're sliding around just a little bit as I weave them. So to make sure each row is pushed up close. And then we're going to finally weave in my exclamation mark. So we're going to go over 2. All right, we're going to go under 2, over 1, under 4, and then over 1. So remember, our Zeros are going to be our unders. Our ones are going to be our overs. And if you want to, while you're getting the hang of it, if you want to say U and O first of all, and then translate that to ones and zeros, you can. Just remember, whenever we say a 1, we're really saying we're going to go over the warp strip. Whenever we say a 0, what we're really saying is we're going underneath. And that's why weaving is so fun and kind of cool, is when we think of it as a binary expression. So what I think you could do as a challenge is you could write whatever secret code you want, make it school appropriate secret code, and you could plot it out on your grid, and then you could, for starters, when you guys are first getting used to it, you could just trade the whole grid and your friend would have to translate. But as you get really good at this, you could either just give them the plotted pattern and they're going to decode it using the binary decoder sheet, or you could just give them the binary code and they're going to weave the pattern themselves and then decode it. So have fun with your binary secret messages. If you have a message for us, take a picture and send it to education@scienceworksmuseum.org. We will decode it and see what you have to say. So have fun and stay curious.